Hello everyone, I am Surbhi. Today we are going to study about complex numbers. So first of all, we will see what are complex number. A complex number is the one that can be written as p plus iota q, where p and q are real values and iota represents a solution to x square plus 1 equal to 0, where iota is equal to under root minus 1. So this is the definition of complex number. So let's see what are complex number and from where complex number originated. If we see if we have an equation x square plus 1 equal to 0 and we want to find the solution of this equation, then this is x square is equal to minus 1 and this is equal to x is equal to plus minus under root of minus 1. And we know that negative under root in real numbers has no value. This is not defined. So we define it by with the help of the iota, that is imaginary number. We take this minus iota under root value. This is under root minus iota is iota. We take this value as iota, so the answer is x plus minus iota. So this is known as imaginary number. So how can we write the complex number? We will write complex number as p plus iota q, where this p and q belongs to the real values and this iota make it is a imaginary value. So this represents a complex number. So let's move towards some examples of complex numbers. So complex numbers are 8 minus 2 iota and 2 plus 31 iota. So if we see this 8 minus 2 iota is a complex number, as this 8 and minus 2 are real values and we have iota with this, and 2 plus 31 iota, similarly here we have 2 and 31 as real values and it has iota with it. So now moving towards the next point, here this is complex number are denoted by Z. So that means complex numbers are denoted by Z. The journal form of a complex number is Z is equal to p plus iota q. As we see, we can write complex number as p plus iota q and it is denoted by Z. So we can write it as Z is equal to p plus iota q, where this p is known as the real part and it is denoted by REZ, and q is known as imaginary part and it is denoted by IMZ. So here what it says, if we have a complex number Z is equal to p plus iota q, the number without iota, this p is known as real part of Z, and the number with iota, this q, is known as imaginary part of Z. Sorry, this is imaginary part. So we can write real part as REZ and imaginary part as IMZ. So here we can write REZ as real part and IMZ as imaginary part, and imaginary part is the part that is with iota and real part is the part that is without iota. So this is all about the complex number. Now moving towards the algebra of complex number. Firstly, we move towards addition of complex number. Here we see if we have two complex numbers, how can we add these complex numbers? So if we have a1 plus iota b1, that means first complex number, plus a2 plus iota b2, second complex number, we can add it as, first of all we add the real values, that means a1 plus a2, then plus iota common, we add the imaginary values, that is b1 plus b2. For example, if we have 2 plus 3 iota and plus 1 minus 5 iota, how can we add it? First of all, we will add the real values, that is 2 and 1. So 2 plus 1 plus iota, here the imaginary value, that is 3 minus 5, so 3 and minus 5. So this is equal to 2 plus 1, 3, plus 2 minus 5 is minus 2 iota. This is equal to 3 minus 2 iota. So this is all about the addition of the complex numbers. Now moving towards the subtraction of complex number. So here, moving towards the subtraction is similar to the addition. In subtraction, we have first complex number minus second complex number. So we will subtract two real parts plus iota common and then subtract two imaginary parts. Taking similar example, we have 2 plus 3 iota. If we want to subtract this, and here we have 1 minus 5 iota, this is equal to, first of all we will subtract the real values, that is 2 and 1. So this is 2 minus 1 plus iota common, Here the imaginary values, that is 3 and minus 5. So this is 3 minus of minus 5. So this is equal to 2 minus 1 is 1 plus iota times this is 3 plus 5, and 3 plus 5 is 8. So this is 1 plus 8 iota. This is the answer of the subtraction of two complex numbers. Now moving towards the product of two complex numbers. So if we find product of two complex number and we have one complex number as a1 plus iota b1 and second complex number as a2 plus iota b2, then what we will do, first of all we will find the product of two real part, that is a1 a2, minus, then find the product of imaginary part, that is b1 b2, then plus iota. We will multiply a1, that is real part of first, with the imaginary part of second, that is a1 b2. Then we will multiply the imaginary part of first with the real part of second, that is b1 a2. So taking example, here we have, if we find the product of 2 plus 3 iota with 1 minus 5 iota, this is equal to, we will multiply real part, that is 2, with real part, that is 1. Here we have 2 multiply 1, that is 2. Then minus 3 multiply minus 5, that is minus 15. Then we have plus iota. Now we will multiply real part of first with the imaginary part of second, that is 2 multiply minus 5, that is minus 10, plus imaginary part of second and real part of first, that is 3 multiply 1, that is 3. So this is equal to 2 plus 15 is 17, plus minus 10 plus 3, here we have iota, minus 7. This is equal to 17 minus 7 iota. I hope this is clear. Now moving towards the next operation, that is equality of complex number. Now two complex numbers are equal, that is a1 plus iota b1 is equal to a2 plus iota b2 if the real parts, that is a1 is equal to a2 and the imaginary part, that is b1 is equal to b2. That means two complex numbers are equal when their real and imaginary parts are equal. For example, 2 plus 5 iota is equal to 2 plus 5 iota. Here the real parts are 2, that means equal real parts, and imaginary parts are 5, that means equal imaginary parts. Now moving towards the some properties of the complex number. So properties of iota. Moving towards the properties of iota, here we will see that iota is equal to under root of minus 1. Now we can find the value of iota square. What is iota square? Iota square is iota multiply iota. That means under root of minus 1 multiply under root of minus 1. So this is equal to under root minus 1 multiply under root minus 1 is minus 1. So we can say iota square is equal to minus 1. Now we will find the value of iota cube. This is can be written as iota square multiply iota, and the value of iota square is minus 1 multiply iota. This is equal to minus iota. So we can say iota cube is minus iota. Now moving towards iota raised to the power 4. So here we have iota square multiply iota square. Iota raised to the power 4 can be written as iota square multiply iota square. Iota square is minus 1 multiply minus 1, that is plus 1. We can say iota raised to the power 4 is plus 1. So this is the value of iota raised to the power 4. So here we can say, if we find the value of iota 5, iota raised to the power 5 is iota cube multiply iota square. So iota cube is minus iota, iota square is minus 1. This is again equal to iota. That means if we find the value of iota raised to the power 6, this must be equal to minus 1. Then iota raised to the power 7 is equal to minus iota. And again iota raised to the power 4, iota raised to the power 8 is again equal to 1. That means iota raised to the power something 4m. Whenever there is a multiple of 4 in iota's power, this is always equal to 1. And iota raised to the power 4m plus 1 is always equal to iota. Iota raised to the power 4m plus 2 is always equal to minus 1. Iota raised to the power 4m plus 3 is always equal to minus iota. This is also some properties of related to iota. Now, with the help of these properties and algebra of the complex numbers, we are moving towards the questions. Here the first question is, if 1 plus iota is divided by 1 minus iota whole raised to the power m is equal to 1, then what is the least integral value of m? So what is given to us? We are given that if we have 1 plus iota divided by 1 minus iota and raised to the power m is equal to 1, then we need to find the least integer value of m. So first of all, as this is in the numerator and denominator, we will rationalize it, and on rationalizing we have 1 plus iota divided by 1 minus iota. This is multiplied with 1 plus iota divided by 1 plus iota, and this is raised to the power m, and this is equal to 1. So we have 1 plus iota whole square in the numerator, and in the denominator it is the identity, that is a plus b multiplied with a minus b is equal to a square minus b square. So from here we have 1 square minus iota square in the numerator, and this is raised to the power m, and this is equal to 1. So we have in the numerator we have identity a plus b whole square. So this is equal to a square plus b square plus 2ab. So we have 1 square, that is 1, plus iota square plus 2 multiply 1 and iota, that is 2 iota, and in numerator we have 1 minus iota square is minus 1, and whole raised to the power m is equal to 1. So here we have 1 and iota square is minus 1 plus 2 iota. In the denominator we have 1 plus 1 and whole raised to the power m. This is equal to 1. So 1 minus 1 get cancelled. We have 2 iota divided by 2 whole raised to the power m. This is equal to 1. 2 get cancelled. Iota raised to the power m is equal to 1. As we see, the least power of iota that makes iota is equal to 1 is 4. So that means iota raised to the power 4 is equal to 1, and this is the least integer. So we can say from here m is equal to 4, and this is the final answer for this question. I hope this question is clear to all of you. Now moving towards the next question, that is question number 2. So here we have if 1 minus iota multiplied with x plus 1 plus iota multiplied with y is equal to 1 minus 3 iota, then x comma y is equal to, we need to find this coordinate, and here we are given 1 minus iota times x plus 1 plus iota times y is equal to 1 minus 3 iota. So simplifying, this is x minus iota times x plus y plus iota times y is equal to 1 minus 3 iota. Here we will add real part with real part, so we have x plus y plus iota common. Now here we have imaginary part as minus x and here as y, so minus x plus y is equal to 1 minus 3 iota. Now using the equality of complex numbers, from the equality of complex numbers we have this real part x plus y should be equal to 1, and this imaginary part minus x plus y should be equal to minus 3. So on comparing, we have x plus y is equal to 1 and minus x plus y is equal to minus 3. So we have first and second equation. Now we will add these equations, so adding 1 and 2. We will solve this equation by method of elimination. So we have x plus y is equal to 1 and minus x plus y is equal to minus 3. On adding, this get cancelled. We have 2y is equal to minus 2. So 2y is equal to minus 2, that means y is equal to minus 1. Now we will put this value in equation 1. So put in y equal to minus 1. If in equation 1 we have x minus 1 is equal to 1. So we have x is equal to 1 plus 1, that is 2. The value of x is 2. So we can write x comma y as x is 2, y is minus 1. So 2 comma minus 1 is the final answer for this question. I hope you understand this concept and these questions. Thank you.